This tutorial will be a two-step stoichiometry tutorial. So let's take a look at the problem. In a very violent reaction called a thermite reaction, aluminum metal reacts with iron 3 oxide to form iron metal and aluminum oxide. How many moles of iron 3 oxide will react with 99 grams of aluminum? So think about the problem. Again, with stoichiometry, the first thing that you need to have is a balanced chemical equation, because the coefficients in the balanced chemical equation will act as your mole ratio. And we always will need a mole ratio because we are always changing from one substance to another. So let's balance our chemical equation. Okay, so now our chemical equation is balanced and the coefficients can be our mole ratio. To figure out which ones we're going to be using, you have to look at the substance you are given and the substance you are solving for. We're given grams of aluminum and we're looking for moles of iron 3 oxide. So the coefficients that we will be using is the one in front of the aluminum, because that's the substance we are given, and the one in front of iron 3 oxide, because that's what we are solving for. Okay, so now I am going to start by writing out my given information, which is my 99 grams of aluminum, and my unknown, which is my moles of iron 3 oxide. So, in order for this reaction to go to completion, we're trying to figure out how many moles of iron 3 oxide would be needed to react with all those 99 grams of aluminum. Now, this becomes a two-step problem instead of one step with only a mole ratio, because look at what we are given. We are given grams of aluminum. And in all stoichiometry problems, you're going to be changing from one substance to another, but you have to use a mole ratio to do that. So everything must be in moles. We can't go from grams of one substance directly to another substance. It doesn't work. We must convert to moles first. And as we know by now, whenever you are going from grams to moles, you need a molar mass. So this problem requires a molar mass and a mole ratio. All right. We have two substances in the problem, aluminum and iron 3 oxide, and you may be thinking, how do I know which molar mass am I going to be using? Well, when you look at the problem, look at what substance the grams is talking about, because molar mass can only go from grams to moles of the same substance. Since we're given grams of aluminum, we are going to need the molar mass of aluminum. We want moles of iron 3 oxide, so we do not need a molar mass of iron 3 oxide at all. So I'm going to look at my periodic table and get my molar mass for aluminum, which is 26.982 grams of aluminum per 1 mole of aluminum. And then the other thing that we needed to write down was our mole ratio, which we already took a little look at because we got our coefficients. So let's write that down for ourselves. For every 2 moles of aluminum, you need 1 mole of iron 3 oxide to react with it. Okay, let's set up our dimensional analysis. In every dimensional analysis problem, we start with our given as the beginning. And then we need to figure out what our next step is to convert. Follow the units. We're given grams, and we know that we can't go from grams of one substance to moles of another substance in one step. So the first thing you should notice is we have grams and we need to get rid of them. The only way to go from grams to moles is to use our molar mass. Here's our molar mass of aluminum. Now notice we're trying to get rid of grams, So the 26.982 goes on the bottom of the fraction and the mole on top. All right. But our problem asks for moles of iron 3 oxide, not moles of aluminum, so we need one more step. And here comes our mole ratio, because once we're in moles, we can go from one substance to another. Remember, the unit you're trying to cancel out goes on the bottom, and the unit you want goes on top. So because we're trying to cancel out the unit of moles of aluminum, this 2 mole of aluminum goes on the bottom, and our 1 mole of iron 3 oxide would go on top. You plug it into the calculator to solve. Now, you can multiply everything across the top and divide by everything on the bottom, or you can do it step by step. So do 99 divided by 26.982, and then divide it again by 2, whichever you would like to do. But you should get that you have 1.83 moles of iron 3 oxide. So try that on your own. If you don't get that, then retype it in.